Verifying the identity cosine of theta over 1 minus sine of theta equals secant of theta plus tangent of theta. Ideally, when we establish or verify an identity, we start with one side, a more complicated side, perform algebraic manipulation, and arrive at the other side. Alternatively, we can start one side, perform some algebraic manipulation, and start the other side, perform some algebraic manipulation unrelated. If we arrive at the same intermediate step, meaning two things equal to the same thing must be equal. What this means is that if we start the left and the right side separately, perhaps not at the same time, but separately, if we can show that both of them equal to some expression, and that if they have something in common, then the two expressions must be the same. To do that, we start with the left-hand side. The left-hand side is cosine of theta over 1 minus sine of theta. And we look at the right-hand side. The right-hand side is secant of theta plus tangent of theta. But secant of theta plus tangent of theta is 1 over cosine of theta plus tangent of theta is sine of theta over cosine of theta. And then we combine these two fractions. They have the same common denominator, cosine of theta, so we can simply add the numerator. So what this means now is that we need to show cosine of theta over 1 minus sine theta equals 1 plus sine theta over cosine of theta. To do that, perhaps we multiply the conjugate to one side. To multiply the conjugate, we multiply the well-chosen one. 1 plus sine of theta over 1 plus sine of theta. The conjugate is a binomial, so there's no conjugate of cosine of theta. It had to be the conjugate of 1 minus sine theta. And we don't just multiply the numerator only. This is the well-chosen one. And so this is now cosine of theta times 1 plus sine of theta over 1 squared minus sine squared theta. This is promising because we introduce 1 plus sine theta, which is the same numerator of what we tried to arrive at. The denominator is the Pythagorean identity. 1 minus sine squared theta is cosine squared theta, but the cosine squared theta canceled out, leaving us with 1 plus sine theta over cosine of theta, and we picked up where we left off. If we follow this sort of logical reasoning, then if it was not live, we wouldn't be able to tell whether we start both sides simultaneously or not. If we read it from the top to the bottom, then each of the steps is reversible, and that is enough the justification. Any of these steps is reversible. What this means is that potentially we can start with the left-hand side only, perform the algebraic manipulation, but how do we know to rewrite the expression at each step certain way? We actually have the target or the result in mind, whether we explicitly write it down or not.